Hello everyone. In this section, I'll be presenting question number 4, where we analyze the relationship between student age and self-assessed learning productivity. We will use descriptive statistics and visualizations to understand how these two variables behave and how they relate to each other. The research question. This study uses feedback from 18 undergrad students and we are focusing on two variables. Number 1, age of the student. Number 2, productivity percentage given by the students. Our tasks include calculating descriptive statistics, creating visual plots, and exploring whether age influences productivity. Now, our data set. Here is the complete data set we are working with. It includes each student's age and the productivity score they assigned themselves. The students ranges from their early 20s to early 60s, which gives us a diverse data set to analyze. Calculating the mean. We start with the mean or the average value. The mean age is 46.44 years, which indicates that on an average, this is a mature group of students. The mean productivity is 28.78 percentage, meaning the typical student rates their productivity at around 29%. These averages gives us the first basic understanding of our data set. Now, finding the mean. To find the finding the median. To find the median, we sort the data and take the middle value. Since we have 18 students, we take the average of ninth and 10th values. Median age equals to 50 plus 52 whole divided by 2 gives us 51 years. And median productivity gives us 30.2% plus 31.2% whole divided by 2, which in total gives us 30.7%. Both median are slightly higher than their means, suggesting a mild left skew for age and near symmetry for productivity. Now, standard deviation. Now we calculate the standard deviation, which tells us how spread out the data is. Age standard deviation is equal to 13.20 years, showing a wide variation in student ages, and productivity student deviation equals to 9.19%, indicating that productivity varies but not as widely as age. In simple terms, students come from a wide age range, but their productivity scores are relatively closer to each other. Talking about the box plots help us quickly understand distribution, outliers, and spread. For age, ages range from 23 to 61 years. Most students fall between 39 and 57 years. There are no extreme outliers. For productivity, scores range from 7.8% to 42.5%. The lower quartile is around 26.5%, the upper around 34.1%. The value 7.8% might be a potential outlier. These visualizations confirm a moderate spread and a hint at slight skewness. Now, scatter plot of age versus productivity. Here we look at how age and productivity relate with each other. The scatter plot shows a clear trend. Students in their 20s shows lower and more varied productivity. Students in their 40s have moderate but inconsistent scores. Students in their 50s and 60s generally show higher productivity. This indicates a positive correlation. As age increases, productivity tends to increase as well. Now, what this relationship means? This positive correlation suggests that older students may possess qualities like better time management, discipline, or self awareness, which can enhance learning productivity. Though the trend isn't perfect, the overall pattern is clear. Productivity generally rises with age. A Q to Q plot helps us check if data follows a normal distribution. For age, points somewhat follow the diagonal but deviate at the extremes. This means age distribution has slight heavy tails due to the wide range. For productivity, points lie close to the diagonal line. This suggests that productivity is approximately normal. This is important because it supports the use of common statistical methods that assume normality. Talking about the key findings and conclusion. To summarize, we successfully calculated mean, median, and standard deviation for both variables. Box plots showed the spread clearly with one possible outlier in productivity. A strong insight emerged from the scatter plot. Age is positively correlated with productivity. Q and Q plots confirm that productivity data is nearly normal, making our analysis reliable. Overall, the study suggests that older students tend to be more productive, possibly due to greater maturity or better learning habits. Thank you. Thank you for listening. This concludes the analysis of question number 4, and I hope the explanation helped make the statistical concepts easy to follow and meaningful. I hope you like it. Thank you.